Welcome to a cloudy but hot day in Thailand. This is August. We're supposed to be cooling down now, but luckily we're inside with the aircon. So, on to the next project. A friend of mine has a broken ice cream scoop. This kind where you give it a squeeze in the bottom and this really cool bar scoops the ice cream ball right out. So you don't have that sticky mess that you can't shake out. Now, the only problem is the gearing system right here is prone to breakage, and you can see the teeth are broken off here, leading to a not very good contact point. And also the gear isn't really long enough to engage the rest of the tooth area, so that's not very optimal. And you can see that something went wrong here because it skipped a tooth, and as you scoop it comes all the way out to here and then only goes back to here. So I offered to design a new gear part here and print it out on the 3D printer. So let's see what happened. Okay, this should look familiar. This is what we ended up with in the CAD system. You can see the gears and the teeth, and we spin around and you can see where the shaft goes in, and it's got a keyway that locks it in place. So I had to learn a few new things, especially about the way it's got a tool that will allow you to put little gear teeth around the shaft. As long as you draw the profile, it'll make the gear for you, then it'll wrap them around like this. So that's pretty cool. Well, that's all good, but I began to wonder about the lifespan of the PLA in this situation with the gears rubbing under pressure many times. So as you might know, PLA is polylactic acid and is actually made from corn. Now, it's easily printable. It's one of the easiest things you can print with, but it's not especially durable, especially in high temperature situations or high pressure situations. Now, it's easy to print because you can have a low print temperature for the printing surface. The extruder is not too bad, around 210 degrees Celsius, and all you need to do is put down a layer of blue painter's tape and the PLA will stick to it quite nicely. Now let's take a look at what it takes to print with ABS. Now ABS is acrylonitrile butadiene styrene, try and say that 3 times fast, and its printability is not quite as good as PLA, and there's some tricky things we're going to need to worry about. But its durability is excellent, and with good mid-level strength and stiffness, I think it's a good idea. In fact, this is what Legos are made from. So if you've ever stepped on a Lego, you would understand why this would be a good material to stand up under the abuse it's going to get as part of an ice cream scoop. With ABS, the printing surface is very hot at around 100 degrees Celsius. The extruder is a little bit hotter than PLA at 220 to 250. But the printing surface, that blue printer's tape would not handle this very high temperature very well. So you have to use Kapton tape, which is a mylar plastic tape designed for high temperature. And you can cause the ABS to adhere to the Kapton tape by either using, strangely enough, hairspray, or you make an ABS slurry by dissolving some of the ABS plastic with acetone, which is commonly known as nail polish remover. Now, the printing software I'm using handles all the temperature stuff for me, the speed of the print head, and all the other things that it has to do. My major responsibility is preparing and managing the build surface, and it's going to take a few times to make sure this works out nicely. The other factor that comes into play with ABS is it tends to shrink quite dramatically when it cools. So, I'm dealing with things on the order of 0.5 millimeter to 1/3 millimeter in thickness, making all the difference and fitting on that shaft and the gears meshing nicely. So I may have to go back and adjust the design in CAD to take into account this shrinkage. Thanks, George Costanza. And let's see what happens with a test print. Okay, as you can see, I brought the gear into Simplify 3D. It's very, very small, so I zoomed it way up. And I've opened up the printer configuration page. And what I did was I changed the material. I had changed the material to ABS and set it for fast printing with the left extruder. So I will feed the material into the left extruder. For the layers, I'm going to have 4 solid layers on the top, 4 solid layers on the bottom. We're going to use a skirt, which will prime the printing material so it's quite nicely extruded. I'm going to turn on the raft. And what that does is since this has a very small contact patch, as you start printing upper layers, the whole thing can come unstuck from the bottom. So by building a raft, it's going to add extra material around the bottom, giving a more of a lockdown attachment to this piece. And we're going to make 4 layers. It's going to go around. I've played with this before. So with infill, we're going to go to 100% on the infill, which is going to make this a solid block of plastic. We need strength. We're not worried about weight. We're not worried about saving materials. So we're going to make a complete block of plastic out of this. We're going to generate support material as the software thinks it's needed, probably to hold up the gears. And because if you just print this circle and then start printing from one layer, you're hanging out a couple of millimeters this way, this is going to droop down because there's nothing supporting it in midair. By checking this, it's going to generate some support material for us. And you can see that by selecting ABS, it's going for 110 degrees on the build platform, and the left extruder is going to print at 230 degrees Celsius, which is the right temperature for ABS. Cooling is off. This ABS does not want cooling at all, and we're going to leave all the other tabs alone. So let's take a look at the simulation of how this is going to print. Okay, here we're in Simplify 3D's simulation mode, and it's going to show us exactly how it's going to print. What we're seeing already is 2 layers of skirt, which primes the printing material, makes sure everything's flowing smoothly. Then we're starting the beginning of the raft, which gives us a larger amount of material to help stick down to the printing bed. Then as it prints north, you're going to see everything else come into play. So I'll just go ahead and let this play. There's the raft, and then we have the start of the gear itself is the blue material. Let me see if I can stop it just right. Yeah. So you can see we now have the keyed hole for the end of the shaft. We can see that empty space in the middle. A little bit more. And now we have the start of the gears. Now the software felt that it didn't need to put in any support material because the ABS characteristics of the ABS and the way it prints is not going to have very much droop here. So it says we don't need any support material. So we're going to go up. There's our gears, are quite nice and long. Then we're going to start drawing the circle and the cone up to the point of the shaft, and we're done. So let's go ahead and export this and load it up in the printer. We'll get the printer set up and start a print. Okay, everything is up to temperature. I put this lid back on the top, which is meant to keep in the temperature. I've never used this when I'm doing my PLA printing. I got a bottle of spray-on hairspray, generic Thai version. Let's hope it works. I have to slowly open this to keep the heat in. We've got the strip for where the piece will be printed, and then another strip is where the printer extrudes a line at the start of each print. I don't know how much to do about hair or 3D printing for that, but let's come back down here, check the temperatures. Temperatures are good, so I'm going to put this here, and we're going to watch it print, good or bad. Okay, wow, we either were prepared or we got lucky, because this is beautiful. Took 19 minutes to print. With the raft, it stayed attached to the build plate perfectly. Everything is just beautifully formed. There's a tiny little bit of slump or sagging, I would call it, at the base of those. But this is printing in fast mode, just as a test. You can see the layers. You can see the defined printing layers. But it was mostly to test the process and also to see if the dimensions focus you. Anyway, if the dimensions were printed properly. So I need to pop the raft off and try and install it into the scoop. But otherwise, things are looking very good. Wow, I am completely blown away. This slipped onto the shaft like butter, and it went exactly into the right place. The gears are perfect. The mechanism is perfect. Sorry, high speed. Doot, 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 doot. The trick is to get this metal to bend all the way back so that it's tight against the backstop. But this is what it will look like after it's fully bent back into shape. But I am so surprised that the ABS piece slid onto the shaft and fit into the keyway absolutely perfectly. I was so worried about having to go in and tweak the design in CAD to make it fit better. But that is incredible. Oh, this is awesome. All right, so now I'm going to print a version of this with the fine setting. It's going to take about 50 minutes, but we should see a lot less of the layering. And then I'm going to go back in and just double check the support material so we don't have this bit of sagging at the start of the gear print. But we are on our way, folks. Okay, the fine print just wrapped up, and you can see it turned out pretty well with the layers. They're very, very, very fine. There's 3 times as many layers in this than there were on the original one, which printed in fast mode. And you can see that difference right here. So cosmetically it's nicer, but the downside is the software refuses to print the support material. So we get this. This is terrible. This is not what I want to be happening for the first couple of millimeters of the print for the gears. And you can see it also happens way up here, focus, where it starts printing the top of the cone. This is not good. It's okay in a couple of places, but generally I'm not happy with this, and especially this. This is no good at all. So I got to figure out how to force Simplify 3D to give me support material, even though it thinks it's probably okay. There's just a couple of millimeters of material sticking out, but that's got to be fixed. Otherwise, I'm just going to go back and print this. We need it to be functional. Doesn't necessarily have to be pretty, but it has to be strong. I think more finer layers will give me a stronger print in the end. But if I cannot make this work, then this is what I'm sticking with, because this is fine. All right, back to Simplify 3D. Okay, with 30 seconds worth of research, I figured out how to force Simplify 3D to use support structures. And you click this button, and I want to make them very, very fine. So I go to the smallest pillar size possible and say, Generate Automatic Supports. Boom! There we are. You can see that it's supporting right here. These columns support the gears, and these columns support the top circle of the cone. So that's exactly what I'm looking for. Let's run it through the prepare process. It's going to take 1 hour and 6 minutes to print, which is only a few minutes more than we had before. It's going to use 1.2 meters of material, which is a little more than double, but that's only just over 3.5 grams of material to print this. And let's run it through the simulation and see how it looks. So if we look at this, let me stop it with there. So this part in light blue is the actual part of the piece. All of this cyan color is support material. So let's watch that print. It's supporting up, and the gears just started, and the support continues up to the bottom circle of the cone right there, and to the top of the cone. So this thing is well supported, and let's give it a shot. Okay, here's the print. It came out beautifully. You can see all the support material. So I just need to take an X-Acto knife and clean that off. Focus. And we'll see how it looks underneath. Well, I have to say there's pluses and minuses to using a very strong printing material. And the minus is it's really hard to get off. I managed to cut the bottom raft off with the X-Acto knife, but you can see how much material has been laid down for the support. And this is just a solid block that's not particularly easy to get off. This is going to take a while. I got to figure out, I don't need a solid block of support material. It doesn't show it this way in Simplify, but it's sure printed this way. Okay, I went back, I deleted all the automatically placed support pillars, and I added my own. I put one 1mm pillar under each gear and 1mm pillar under the base of the cone. So it's just enough to keep everybody happy, but not too much material to go crazy. I also dialed back this number, the extra inflation distance. This is what was making the support pillars far too big. So I said, I don't want any extra. And then if we simulate this, we can see we've got very small 1mm pillars, which will be easy to cut off with an X-Acto knife. And we go up, and the start of the gears is right there. So the gears are supported, but then between the gears up to the bottom of the cone, we're going to see that. Right there. The bottom of the cone is supported, and I think we're getting closer to our final print. Looks good. 254 layers in fine setting with just enough support. Okay, here it is, hot off the printer. We can see we've got significantly less material, and all the support material here is kind of rough, but all of this comes out, and then the support material between each of the gears, but the bottom of the cone is looking good, and the teeth themselves are looking very nice. Okay, I cut off the bottom, and this is what I'm looking for the supports to just gently come out. Oh, I might have taken them all. See, I can just pop that out with a finger, and the support comes right out. Look at that, very nice. Now I'm around to the back side. It's going to be a little more difficult. Okay, a little more tidying and we'll see how it looks. Well, that was easy, and just a little cutting with the X-Acto knife gives us our good shape. We have no slumping underneath the cone. We have no sagging or slumping underneath the bottom of the gear or this offset part here. Focus. The only problem I see is wherever the plastic is exposed to a little bit of force, it turns this white color. And I've seen this with other kinds of plastic, so it's not surprising that it's happening here. But every time it seems I want to make a bit of a trim, then something turns white. But that's alright. We're more interested in function over form here anyway, as the train goes by. I'm going to try and just give this a little rub with some acetone, because I believe acetone is a solvent for this, and we'll see if we can just clean up a little bit of the rough surfaces. Okay, a little judicious use of some acetone and a Q-tip, and most of the white spots are gone, and the part is looking really pretty good, about as good as I could hope for the quality of my home, what does AVE call them? Home player, something like that. Home player quality machine. So this is going to do the job, and it's going to look good, and it's going to be strong. So, mission accomplished. Damn, now I want some ice cream.